All right, good morning, everyone. My clock shows 10 a.m., so I will get started on time and we'll try to finish on time as well. I wanted to welcome everybody to the Arkansas Semiconductor Business Leader Summit. Power Technology is thrilled to be sponsoring this important summit, and we really look forward to seeing what comes out of it. I also want to say a special thank you to those of you who are attending from the state legislature and from the Arkansas Economic Development Commission. We think it's really important to have all types of participants in today's meeting. And I think you'll see from the panelist discussion, we've got people joining from the component sector, from the equipment sector, from the academia sector, and from the instrument side. So really excited to have such a wide array of people from Arkansas participating. So I am Walter Burgess from Power Technology. I'll be hosting or emceeing or whatever you want to call it today. And we'll be talking about a couple of different things. One, I'm going to give you a brief introduction to the CHIPS and Science Act. And I promise I'm not an expert on this yet, but I am working to be an expert on it. And then we're going to hear about the semiconductor activities that are happening here in Arkansas. Matt Francis will tell us about some component chip designs that are happening here in the state. Kirk Warden will talk about components that are being manufactured at OEM scale. Hugh Churchill will talk about things from the academia universe that are happening, some exciting news about quantum. I'm going to say quantum physics, and then I'll also present from a device side as a part of the supply chain for semiconductor equipment. Then we'll have a chance to hear from Jennifer O'Brien. She's got a great federal perspective of how the CHIPS Act is structured, and I've heard this presentation before. It's really exciting. And then another Jennifer Fowler will present, sort of a state level perspective on how we get federal funding into the state. And then we'll have an open discussion at the end, and we'll open up the microphones for everyone to ask questions. And the chat box is open. If you want to get your question in early, you can send a question in the chat box and we'll get your question. So we're going to hold all the questions until the end. That way the presenters can get through their information that they're imparting to us. And that'll just help us preserve everybody's time and respect your time. So who's participating today? It's a really a diverse group of people from all parts of the state geographically, from Northwest Arkansas to south of Little Rock. So we've got public companies, private companies, researchers and entrepreneurs, and even some members of the legislature. And so it's a real mixture of people, and we're grateful to have all of you attending. So let's set the stage and talk about what is the CHIPS and Science Act. Probably everybody in the room knows more about it than I do, but for those of you who know less than I do, let me just give you a very quick primer. The CHIPS Act, really relates to the modern world and the devices that we use every day, whether it's your cell phone or your laptop. We're all dependent on semiconductors in some way. Even though the United States invented a lot of the semiconductor chips and the technology that goes into our everyday devices, unfortunately, most of the production of these chips happens outside of the state. You can see that outside of the United States. You can see that logic chips and memory chips have a real strong manufacturing presence in Asia. And unfortunately, that geographic location of that supply chain puts the United States at risk. We've all witnessed some recent supply chain challenges, everything from baby formula to automobile parts. Some of those were semiconductors as well. We've seen invasions and geopolitical things that affect our supply chains in Russia and Belarus. And then we've seen how the pandemics and other global events influence our supply chains. So the United States decided that they did not want to be dependent on other countries for supply chains. And so in the area of semiconductor chips, the president and the administration wanted to put in some reaction to that and make sure that we had our own supply of chips. So they didn't want the United States to be dependent on foreign countries for its supply chains and its security. So the CHIPS Act seeks to create an advanced semiconductor ecosystem within our own borders, and this will help us create resiliency in our own supply chains, and it will strengthen our national security. So this is an investment by the government, but it also should not be solely an investment by the government. And I think we'll hear today how some of our private industries and public companies can all participate in this effort. So I've stolen all of these slides from the National Institute and Standards of Technology. So if you want to know more about these things, if you want to know more about this topic, their slides are much more in depth. I've only cherry picked a few of them. So the CHIPS Act will return some of the leading edge manufacturing to the United States. We are still a leader in this area, but some of our expertise has gone overseas. And so the CHIPS Act will help maintain our technology leadership in the world. The CHIPS Act will also help us expand capacity to make both current and mature chips and the critical supplies that go into those chips. Just yesterday or the day before, Georgia announced a $600 billion investment outside of Atlanta for critical supplies in the semiconductor industry. So the CHIPS Act will also reinforce the U.S. Strength in designing and equipment. And the equipment is a very vital part of this as well. And we'll talk about that a little bit later. And then lastly, it's intended to grow the U.S. workforce and strengthen the communities where those workforces are located. Overall, it's really about an ecosystem at the national level, and that starts at the state level. And that's what brings us all here today. So before we all get too terribly excited, we do have a little bit of a timeline, and we have some time here in the federal process. We're only here in the fall of 2022, and the government's program is not designed to start pushing out investments until later next year. So just wanted to show you the timeline and to reinforce the point that Arkansas, by having this summit, we're getting in on the ground floor and being able to get ourselves organized before the federal government does in some ways. So I want to be clear what the CHIPS Act is and what it isn't. On October 7th, the federal government announced some export control measures for semiconductors, and the CHIPS Act is a separate piece of legislation. It has nothing to do with the export controls, other than we're talking about the same geographic areas and the same technology. But beyond that, they are related only by subject matter, but we're not talking about the export control measures, but they are a very important and real part of this conversation. So we're here today just to present some information. If the information that's presented today is compelling, then we as a state and as individual companies we'll need to decide what actions we should take in the future. The answer may be we don't need to do anything, or the answer may be that we need to do some additional steps and put in additional effort. But we're going to leave that up to you as the attendees and the panelists at the end. My goal today is just simply to present information and then let the conversation take its natural course. So we've talked a lot about the federal levels and what the federal government is doing. I want to pivot at this point and start talking about some of the state level topics. And so to facilitate the state level conversation, we've got a group of panelists that have about 10 minutes apiece to tell us really what's happening here in the state of Arkansas and in the world of semiconductors. And like the photonics industry, a lot of individuals don't really understand how big and how important the semiconductor industry is and the photonics industry. You know, we in Arkansas, we don't brag a lot. I guess that's a Southern attribute, but there's a lot of very vibrant technology happening in the state. And today we want to highlight some of that technology from the semiconductor sector. So with that, I'll ask Matt Francis, president at Ozark IC, to tell us what's happening up in his part of the world.
Thank you. Okay, are you said you want me to share or see?
No, we have your slides if you'll just take
good.
control.
Perfect. Okay. Okay, so yeah, so thank you, Walter. My name is Matt Francis with Ozark IC. So we founded Ozark IC a little over a decade ago. We are in Northwest Arkansas, currently about 20 employees. And what we do is, at a high level, is enable electronics for extreme environments. And so what that is basically anywhere where you go beyond a kind of a mill standard part, Ozark IC tries to address those spaces. So high temperatures, high vibrations, things like that. Let's see. There it goes. Okay, so so this is an example of some of these environments. This is places like control of jet engines, geothermal and oil and gas energy exploration, even starting to get into things like nuclear reactor technologies. We've been in the planetary exploration space for a while. It's not a big market, but it's critical for science. And then there's sort of peripheral places that are very strategic for national security, like hypersonic technology. We're doing a lot of the research level work in those spaces for folks like DARPA, and then there's other commercial applications like high performance transportation and electrification. But again, the environments we work in are extreme temperatures, could have radiation effects, corrosive environments, mechanical stress. But one of the real differentiators semiconductor-wise is our ability to work in extreme temperatures. And this is what we build. This is our product. It's an X node or extreme node, single board ruggedized computers. And so I think for this crowd, it won't be hard to explain. But you can think of, if you're familiar with a Raspberry Pi or a Arduino, we make those kind of single board computers, but we make them that work at very high temperatures. Our lowest temperature product that you see at the top is 200 degrees C nominal operation. We develop currently offer computers at 250 C all the way up to in development up to 500 and 800 degrees C. These allow us to do data acquisition, actuation, closed loop control across a lot of different markets. Let's see, trying to get the next slide. There it goes. Okay. And so what's the, why are we working in these spaces? Compared to commodity semiconductor, these are relatively small markets, but they are not trivial markets. For example, for jet engine control, we develop high temperature smart sensors and control modules. Centralized control is what they've done to date. Most common out there in the aerospace market. These are really heavy. They have to be thermally managed, and we can save, $2,500 is what it costs per year in fuel. That's only going up right now for every pound on an airplane. So you can see why you'd want to digitize, get smaller, get smarter. For space exploration, $10,000 per pound to launch. They keep trying to drive that down. It's very expensive. I've had one payload on the space station And I think it cost $250,000 to get 3 boards in space. So it's every pound you can save there is very critical. For energy, that this is a area that we've worked heavily in. They're really expanding into new clean energy sources, geothermal. It can cost $20 million to drill a well, and the folks will tell you their hit rate's about 50%. So you can imagine if you have to make all those wells work. Right now they're drilling blind, and so if you need eyes and ears, that's digital electronics, computing, sensing lets you do that. Next slide.
It's a little slow in transition.
Okay. So to do this, and why we're here today, I'll kind of work from the bottom. Obviously, if we're going to making stuff like this work at elevated temperatures, we need advanced semiconductors. So Ozark actually started out in this space exclusively. We were what you would call a fabless design center. Those are predominantly on the West Coast, some on the East Coast, but they're your classic IC design center, fabless in that they don't do their own fabrication, they do design. We still do quite a bit of that, but what we found in our space is that not just making the semiconductors work at those temperatures, you also have to surround them with everything else. And so we've also become a packaging center. We manufacture advanced ceramic substrates to put the chips on, and then do all assembly in-house and co-design of all of that together. And so that's at the top. You can kind of see how that all comes together. So you have chips there scattered across the board, manufactured at different centers, some of them in the US, some of them not. We would like to have, for our customers, they would love to be able to manufacture all those chips in the US. Substrates made in Arkansas, assembled in Arkansas, and then shipped to our customers in military, aerospace, and energy sectors. So to do this, we are, again, I kind of mentioned this already, we're a full-featured ceramic wiring board production facility. We've brought this up online in the last 2 years. We do both kind of simple post-fired boards, co-fired boards. We also do advanced assembly in-house, wire bonding, flip chip, and then full rapid module prototyping. So we actually make harnesses, assemblies, cases, and then test everything. We actually use a lot of additive manufacturing for quick turn prototyping. It's exciting space to be in with respect to electronics, and I think it's one of the places we're kind of way out there ahead of folks in reducing the cost for these extreme environment electronics. And so, how this all works together, and thinking about, supply chain, is that we do the chip designs. Not just that, we also work with the semiconductor manufacturers. I work with fabs all over the United States to specify the semiconductor processes. So we work in some pretty exotic semiconductors like silicon carbide, silicon on insulator, and actually develop new processes in collaboration with those fabs. Very happy to say that we've been able to have those relationships with U.S. fabs, and those continue to grow. I think the CHIPS Act's really important for that. Again, we put that all together on a substrate that we manufacture, assemble that, do mechanical design, assembly, and then put it all together as a complete solution. And of course, one of the key parts of that where we have to do a lot of testing characterization, and we'll talk about that in the workforce development. We need skills across all of these different areas to do what we do. And then it said challenges and opportunities. The IC supply chain. I'm very excited about from the CHIPS Act that we are seeing investments. I'm already seeing investments and announced investments in partners that we currently have. They're not in Arkansas, but that's not a huge deal. That we need fabs in the United States. There's pros and cons to having a fab in your backyard. It's not the cleanest industry in the world. That's one of the reasons that a lot of them got moved overseas. But one of the things to take away from this to discuss is that more fabs in the U.S. is good for Arkansas, even if they aren't in Arkansas, because again we are tightly integrated in the U.S. supply chain of electronic systems, and so the more components that can be manufactured in the U.S., the more that we can assemble, design in those spaces, and ship to our customers. And for us, that's energy and aerospace. This is, as I said, this is an interesting stat. If you know, what bridges between you know, your final assembly, so like PCB level and complete system, and then all at the other extreme, the IC is packaging. And advanced packaging is what everything's kind of moving towards. This is how we, you know, the most common example of this is how your cell phone's put together. It's a chip stacking and heterogeneous integration and lots of basically kind of in that middle space, not just soldering components to boards, but dealing with things at the individual chip level. The less than 5% of that market's currently in the US. This is a very high margin market, and it's growing, I mean, very quickly. This is just one of the, you know, many market studies. You can see it's a growing, estimated to be a $55 billion market by 2026. It's really a great fit for Arkansas. We're you know, but we need to be positioned to continue to grow our workforce to support that kind of industry. You know, and that's one of our challenges. Less than 24% of the citizens in Arkansas have a higher ed degree. You know, all advanced packaging skills don't have to need advanced degrees. So I think that's one of the areas where we need to create workforce programs. And as CHIPS Act rolls out, I think there will be opportunities for us to be very well positioned off of our existing industries and serve a broad spectrum of people in our in semiconductor, whether it's, like I said, whether it's doing IC design or all the way through packaging and systems assembly. And then my last thing is, I said, I think this is a natural fit for Arkansas. You know, we're a state, I think that we're practical people that we're good with working with our hands. We're known for manufacturing. I don't want to steal thunder from Jennifer, but that's a slide from AEDC on, you know, all the different aerospace companies in Arkansas. You know, as we're moving up the supply chain in aerospace, we're going to see more and more electronics assembly. That's becoming a big differentiator for aerospace is electronics. We're in a central U.S. position, and I put some stars on there. If you look at where some of the big new fab announcements are being made, Dallas, Austin, Ohio, we're right in the middle. And so we're in a great position to make use of this of what's already been announced with new fabs and fitting into that ecosystem. And they're kind of our neighbors. I like to joke that I say that there's a new coast forming in the middle of the U.S. in the heartland, and we're right at the middle of it. If you look from Houston up to basically Houston up to Chicago, that's a new heartland, that's a new coast, and we're right in the middle of it. We're in a very good strategic location, and we're an accessible state. We can all work together very quickly to take advantage of these programs as they roll out. So that's really all I had, and I want to thank Walter for taking the time to put this together, and I look forward to continuing the conversation and making sure that to the best of our ability, the CHIPS Act is something that the state of Arkansas can take advantage of.
Well, thank you, Matt. That was quite impressive. And I don't think most people understand just how impressive that is, but to design semiconductors here in Arkansas is a phenomenal thing. And you guys have built a great company there. So let's move up the value chain and talk about components that are used in the semiconductor manufacturing process. And I believe Kirk Warden, president at LaCroix Precision Optics, is here. And he's going to tell us about how optics are an integral part of semiconductor manufacturing.
Thanks, Walter. I appreciate you putting this on today. This is, I think this is going to be really constructive. My name is Kirk Warden, and I'm the president of LaCroix Precision Optics, located in Batesville, Arkansas. Company's been around since 1947. And it was started with surplus equipment after the optics war effort in the early 40s. The company's operated in the Chicago area for several years, but we've been in Batesville since 1966. LaCroix is basically a generalist optics component manufacturer. We serve a wide array of industries from biotech, like OEM device manufacturers, to the defense industry, to space exploration. And also, we are helping to support lots of cutting edge technologies, such as LiDAR, self-driving cars, etc. In general, LaCroix has not traditionally served the semiconductor market very much, just because of the nature of the optics that we manufacture. The role that optics play in semiconductor manufacturing, as you can see on my slide there, a lot of it has to do with the metrology. So using very high-end optics to go in and inspect these silicon wafers after they've been printed. One of the challenges in optics manufacturing for the semiconductor industry is most of these optics are operating down in a low wavelength in the UV, and that makes the manufacturing tolerances more critical. So these are manufacturing optics to very, very tight tolerances. I would say that in general, the optical component manufacturing industry is very tuned in to semiconductor. The companies that are in the United States, we all serve niches, and there are several optical component manufacturers that are that specialize in this type of optics. In order to do that, it takes quite a bit of capital investment in equipment capable not only of manufacturing optics of this caliber, but also to lay down thin film coatings that operate at that wavelength as well. Obviously, LaCroix is very interested in participating in this and helping to support this industry. And so, we would look forward to, as this CHIPS Act goes into progresses, we would look forward to maybe working with academia and looking for some grants so that we can help move into that area, but it will take quite a bit of capital investment. The other thing that Matt mentioned is a critical component to the U.S. succeeding in this semiconductor effort is going to be workforce training. And I know my industry is investing heavily in this. We've got a program that's funded by the DoD to help stand up optics manufacturing technician training sites at community colleges around the United States. And so perhaps something maybe Arkansas can help coordinate with that effort. And not everybody's making optics. You're talking about packaging of semiconductors. Maybe you can craft a training program that is more suited to general semiconductor manufacturing. I think that's about all I have to say about on this subject. We can talk a little bit more later.
Yeah. Thank you, Kirk. That's quite wonderful. I've had the pleasure of touring Kirk's facility down there in Batesville, and you'd be surprised at the level of precision that they create optics to. I think people will be astounded to know that it's somewhere around 1/1000th of an inch accuracy, and the thin films that they deposit are just incredibly thin, and some of those are just a number of atoms thick. So it's pretty impressive technology there at LaCroix. All right, so that's a component level. So let's look at an academic perspective. And Hugh Churchill, Associate Director of the Monarch NSF Quantum Foundry is here to talk us through some of the interesting things that are happening at the academic level.
Great, thank you, Walter. Good morning, everyone. It's a pleasure to talk on this panel. So I want to talk about two things. First, sort of what's going on in the semiconductor space at U of A, and then what do we need to be able to really realize our potential here and do more. So, we've already heard from Kirk and Matt about the need for workforce development, and to state the obvious, as a university, our primary mission is to educate students. But we can, because we're a research university, we can not only, teach students to read and write and think well, we can also engage them in research projects that can give them skills that would be transferable and useful in the workforce. And so as the CHIPS Act builds up, all of these fabs, we're going to need lots of people to actually work in them. But I would hope that, the students that we train don't just all go to, Texas and Oregon and Ohio, but can contribute to the semiconductor industry here in Arkansas. So this slide is an overview of, let's see if I can. Yeah, this slide is an overview of sort of the four main areas that are happening at U of A. The biggest one is in power electronics, so led by Alan Mantooth, but lots of other faculty members represented, as an effort to develop silicon carbide electronics. So they have this big new fab that's going to be built over the next couple of years called MUSIC, the Multi-User Silicon Carbide Center. For a long time at U of A, we've had expertise in molecular beam epitaxy growth of materials. So this is the very large facility that's been assembled over decades by Greg Salamo that can grow nitrides, oxides, 3,5 semiconductors, group 4, and also new activities in 2D materials. Fisher U has built up significant capability in the infrared and night vision space using silicon germanium tin semiconductors. So they make, for example, infrared lasers using those materials, and recent funding is going to allow them to acquire an ASM reactor that will be the first, industrial scale machine for depositing these materials in an academic setting in North America. And then the last one that I'll highlight is the one that I lead here, the Monarch NSF Quantum Foundry. And the idea there is to dramatically accelerate the pace with which we can explore atomically thin two-dimensional materials for applications for various quantum technologies. And so all of these efforts, all four of them have been supported by federal funding on the order of $20 to $30 million or more in the case of power electronics, depending on how you count things. But I actually want to make a different point, which is that the expertise that exists on the U of A campus is actually much broader than this. And so I would like to make a point that there's a lot of underutilized talent and expertise in the area of semiconductor device fabrication. So just to take my example, here's a picture of me from about 15 years ago. I basically lived in the Harvard clean room from the decade of my early 20s to early 30s. But all of the knowledge that I gained working in that environment about how you operate and maintain one of the best academic clean rooms in the country is basically useless currently at U of A, because we do not have such a facility. And there are similar stories that could be told by this group of 45 faculty members on the U of A campus, all of whom have some need for being able to process their materials and fabricate devices, based on those materials. And so to transition to the real need that we have on the U of A campus, it's for a clean room user facility that would be general purpose. So, we have these specialized facilities that have been built up for silicon carbide and silicon germanium tin and now 2D materials, but there's really not a high quality general purpose semiconductor device fabrication facility that could also be primarily focused on training students in the various processes that are needed to create these devices. So this is a picture of the U of A Nano Institute, where I'm located. And there's actually unfinished space in the back of the building that was originally planned for a clean room facility. And so we have preliminary designs for what this could look like. So there's space for about 5 bays that could be used for, the typical things you would expect: lithography, etching, deposition, metrology, and one thing you might not expect, which is biomedical applications. So there's a new Institute for Integrative and Innovative Research here that's going to be focusing in part on implantable medical devices, and they need clean room space as well. And so it turns out that we need, based on preliminary planning, somewhere to the tune of $15 to $20 million to complete this space and outfit it with equipment. And actually, the U of A Board of Trustees authorized $10 million for such a project last year. Unfortunately, the budget, is down around 7, so we're kind of less than half of where we would need to be to actually do this well. And so I think, if I were to say, what's the biggest thing that we could do at the university to make an impact on student training and, the ability to generate that workforce in Arkansas, it would be the construction of this facility. That's all I have. Thanks.
All right. Well, thank you, Hugh. I appreciate that. That's quite the facility you have there. I think I've walked past it, but not been inside yet. So that's awesome.
Come over sometime.
Yeah. Well, that's great. So, as a participant in the semiconductor industry, Power Technology also has a vested interest in the success of the CHIPS Act and the semiconductor industry. So let me just briefly tell you about what we're doing here at Power Technology, if I can get PowerPoint to cooperate. So we are a precision laser manufacturer. We like to say that we deliver precision light, and that our customers make a lot of decisions based on the precision of the light that we deliver. Our customers are primarily the Fortune 500 companies, and many of them are involved in the semiconductor industry. Lasers like optics are a critical part of the semiconductor manufacturing process. They do everything from measuring the texture or the surface of the laser. They can detect a curvature in a wafer. They can measure the thickness of thin films down to the angstrom level or the atomic level, which is really critical. Lasers are really good at measuring particle sizes and contamination. One piece of dust on a wafer can ruin several microprocessors or whatever's being grown on the wafer. And so lasers are vital to help control the quality of the wafer. So here in Arkansas, in Alexander, Arkansas, just outside and south of Little Rock, we have a complete facility that manufactures these precision lasers. We also do quite a bit of testing to make sure that the lasers perform as expected. And then we design everything here as well. So we have a team of mechanical, electrical, and optical engineers that design every product that we manufacture. We export these lasers on a global scale. Many of them go to places like Israel, Belgium, United Kingdom, or Germany, and they get integrated into semiconductor equipment as well as other types of bioanalytical equipment. I can say that we have hundreds of lasers installed in foundries all over the United States and the world, with some of the very largest players in the semiconductor industry. So these Fortune 500s really value having a precision light source that they can depend on running for 365 days a year. So from our part, training is a big part of what Power Technology could benefit from the CHIPS funding. If we could find a way to bring some of that funding to Arkansas, Power Technology could also see expanding its clean room facilities. We already have one clean room facility here. It's not a super classification, but it is very adequate for our needs. So we could see the ability to improve that clean room facility here in Alexander. We could also see the prime opportunity to improve our test and measurement capabilities, just to make sure that we're able to measure the lasers that the semiconductor industry needs and measure them well. Much of our current work is in a new field of ultraviolet lasers. And so to expand and deliver more ultraviolet lasers, we're going to need different equipment than we have now. And so that test and measurement capability would be critical to help meeting the needs of the semiconductor industry. We also have opportunities to expand our production, our capacity. These more complex lasers need more square footage to manufacture. Training workforce, we've talked a lot about, and that may be something we need to discuss at more depth and detail at a future date. But ultimately, we're very invested in the semiconductor industry and happy to do anything we can to help promote that industry within our state. So I'm the last panelist presenter. So I'd like to shift gears a little bit back to the federal perspective. And Jennifer O'Brien is the Government Affairs Director at the SPIE, which is the International Society for Optics and Photonics. And in clear disclosure, Kirk and I both belong to this industry group. It's one that promotes optics and photonics. And so we're very thankful to have Jennifer O'Brien present this morning.
Hi, thanks, Walter, and hello, everyone. Here, let me see if I can get the screen to work. There it goes. So I'm here to talk about the CHIPS and Science Act and all the opportunities that exist for our optic and photonic community as a result of this legislation getting passed. And of course, we're looking toward what implementation looks like at this point, but kind of want to lay the land on what all happened to get us to this place and what all was included in that piece of legislation that is now law now. This is just to show you how it actually made it through Congress, which given today's political situation, it's quite bipartisan. 17 Republicans in the Senate and 24 in the House joined Democrats to get this bill through Congress. A huge accomplishment for the scientific community. It's something that we were lobbying really hard for, and this was signed into law on August 9th of this year. So a done deal all the way through and signed into law. So now we're moving forward and looking at how to get this money out the door. So this is a big picture view of what was in the CHIPS Act portion of the bill, not the science portion, just the CHIPS portion. So high level, $50 billion was allocated over 5 years for the CHIPS for America Fund. And I'll do a deeper dive on this, but this includes the incentives as well as the R&D portions of the bill. There's also $2 billion included for the CHIPS for America Defense Fund. And again, I'll talk a little bit more in detail about what that includes later. And then there is $500 million included for the CHIPS for America International Technology Security and Innovation Fund. And essentially what that is money for the government to coordinate with our allies on not only semiconductor manufacturing, but other emerging technologies of importance. And then $200 million is provided for the CHIPS for America Workforce and Education Fund. This is going to NSF. And they'll definitely have their work cut out for them because it is estimated that we're going to need an additional 90,000 workers by 2025 as a result of these investments. Moving on into a deeper dive of what the CHIPS for America Fund looks like. So actually, when I drafted this, they just said Department of Commerce in the legislation, but we now know that NIST is going to be handling both the incentives program as well as the R&D program. And what that constitutes is $39 billion in financial assistance to build, expand, and modernize facilities and equipment for semiconductor fabrication. It also includes $6 billion that can be used for the cost of direct loans and loan guarantees. On the research and development side, there's $11 billion provided for establishing a national semiconductor technology center, a national advanced packaging and manufacturing program, a manufacturing USA Semiconductor Institute, and microelectronic metrology R&D. And I'll go a bit more into all of that in just a moment. So looking at the incentives program, that's the $39 billion over 5 years. Of that, $2 billion is explicitly provided for legacy chips or mature nodes to advance our economic and national security interests. And as I mentioned before, $6 billion provided for the cost of direct loans and loan guarantees. $19 billion is provided in fiscal year 22, and that includes the $2 billion for the legacy chip production, and then $5 billion each year, fiscal year 23 through fiscal year 26. So a lot of money that needs to go out the door. And as Walter did a good job of giving the timeline of what that looks like on actual proposals and things like that. So it is a little ways off, but the funding exists, real money exists, and it will be going out the door at some point in time. There were also some further details provided in the legislation on who qualifies for this funding. And specifically, it notes that the program includes upstream suppliers of semiconductor manufacturing equipment and materials used to manufacture semiconductors. Of course, that language is hugely important to our community. Actually, earlier iterations of this language did not include, or of this bill did not include this language, and we're very pleased that it got included in the final package. It also says that receiving entities ensure consideration of a broad range of semiconductors and the relevance of the technology to supply chain vulnerabilities. It establishes additional criteria, including requirements that covered entities must have plans in place to identify and mitigate supply chain risks. So things to keep in mind as you're considering applying for funding. As I mentioned before, $2 billion specifically is set aside for mature node technologies, specifically a priority for critical manufacturing industries such as the automotive industry. It also provides an Department of Commerce other transaction authority, just to let you know, it's just a way for the Department of Commerce to cut through red tape, the normal bureaucratic red tape when it comes to getting funding out the door. So it gives them some authority there. It also has some language on construction projects that are happening in underserved communities. There's some stipulations that are provided in the Public Works and Economic Development Act in relation to that. It also prohibits recipients of federal incentives funding from expanding, building new manufacturing facilities in certain advanced semiconductors in specific countries that present a national security threat to the United States for 10 years. I.e., you can read this as China. I'm sure there'll be other countries that are on the list, but essentially they don't want companies that are receiving funds to expand or build new manufacturing facilities in China using this funding. There's also some language on diversity and inclusion and assigning personnel within the Department of Commerce, specifically looking at recipients and making sure those incentives are, that the manufacturing incentives are reaching their commitments in regards to diversity and inclusion. Moving on, if I can get it to go. There it is. Now moving on to the National Semiconductor Technology Center that's going to be established. This is going to be a public-private partnership to conduct advanced semiconductor manufacturing, R&D, and prototyping, invest in new technologies, and expand workforce training and development opportunities. So in fiscal year 22, they received $2 billion to establish this technology center. And then the way the language works for R&D programs for all of them is there's an initial fiscal year 22 amount, and then there is a pot of money provided for all the R&D activities from fiscal year 23 through 26. essentially giving NIST, the National Institute for Standards and Technology, who will be running these programs, some flexibility on how to fund these various activities, R&D activities going through NIST. So still a ton of money out there, but exactly how that's going to play out in amounts over this time period is a little bit of an unknown at this point in time. Moving on to the National Advanced Packaging Manufacturing Program, it's also going to be established and led by NIST. And this, in coordination with the center that's going to be set up, will strengthen semiconductor advanced test, assembly, and packaging capabilities of the domestic ecosystem. It will also coordinate with a Manufacturing USA Institute that's called for as well. The amount provided for fiscal year 22 for this activity is 2.5 billion. And then of course, the flexibility to provide additional funds from fiscal year 23 through 26. And then there's microelectronics research at NIST. And this is a broader kind of carry out microelectronics research program to enable advances and breakthroughs in measurement science standards, material characterization, instrumentation, testing, and manufacturing capabilities to accelerate the underlying research and development for metrology and the next generation of microelectronics. So kind of a broad mandate there for NIST. And they provide 500 million for these R&D programs in fiscal year 22, and again, an undetermined amount in fiscal year 23 through 26. And then there's also going to be the creation of a Manufacturing USA Institute. In fact, I've heard there's possibility there could be more than one institute that is established as a result of this language. And of course, specifically focused on semiconductors. And fiscal year 22, they provide 500 million for this Manufacturing USA Institute, and then an undetermined amount from 23 through 26. The Chips for America Defense Fund. So also it is referred to as the Microelectronic Commons, which has already been established under DoD. And this, the Commons is established to reduce barriers in innovation and enhance infrastructures, namely the kind of lab to fab testing and prototyping through hubs. And so these hubs are established through DoD. They usually use existing facilities and provide funds to establish an expansion into the type of prototyping that's needed specifically for the DoD. And they've already contracted and provided 117 million to Global Foundries to begin US production of some critical microelectronics. But they have 2 billion over 5 years provided as a result of the Chips for America Defense Fund toward these activities through the Microelectronics Commons. And the last one, also I think very important to our community, there was an advanced manufacturing advanced investment credit provided in the bill. Provisions creates a 25% investment tax credit for investments in semiconductor manufacturing that includes incentives for the manufacturing of semiconductors, as well as the manufacturing of specialized tools and equipment required in the semiconductor manufacturing process. Taxpayers may elect to treat the credit as a payment against tax, i.e. direct pay. The credit is provided for property which is placed in service after December 31st, 2022, or for which construction begins before January 1st, 2027. So definitely something our community would have an opportunity to take advantage of, seeing that includes the semiconductor equipment side as well. And then quickly on the science portion of the CHIPS and Science Act. So unlike the CHIPS portion of the bill, which was actually appropriated funds, those are real dollars that don't need to go through another appropriation process or anything. They're a done deal. But on the science bill side, funding increases were authorized for the National Science Foundation, the Department of Commerce, and NIST, as well as DOE Office of Science. But all of this is just authorized funding levels unless Congress appropriates these funds through the regular appropriation process. They don't become real dollars. So it's like we would like to have this happen, but unless appropriators make it happen, it doesn't become reality. And there's some funding in here that I think our community really could take advantage of, especially funding increases being called for the National Science Foundation Tech Directorate. And I'm sure some of y'all might have seen the request for proposals for the innovation engines. I know a lot of people applied for those. So those types of activities are things that would be going through the NSF Tech Directorate. So I think that's a lot of things that could be going out to, especially our industrial community, to be able to take advantage of. Also, this regional technology hubs in the Department of Commerce is something that when you read that language, honestly, it reads optic and photonic clusters to me. Like that's funding that we could definitely take advantage of in our community if it's appropriated. And they asked for 10 billion over 5 years for these technology hubs. So I think making sure this funding actually becomes a reality could be really important to our community. And again, NIST, I mean, hugely important as I've been talking about. So increases across the board for NIST and their activities, which I think would be incredibly important. And we're going to be advocating for, especially in fiscal year 24, for Congress to hit these funding marks that were provided in the bill. And if anyone's interested in being kind of a part of those activities, we're definitely going to be having what we call a fly-in in Washington, D.C. early next year. In March is what we're looking at doing through the National Photonics Initiative. And our primary push will be hitting our science funding targets that were provided in the CHIPS and Science Act. So we'd love to have y'all come and advocate for your congressional representatives here in DC to back those numbers. So more on implementation, and I'm going to start at the bottom of the screen and work up. So the chips.gov site is up and running. If you have not checked that out, would highly recommend doing that. This is actually a screenshot from that website. It's incredibly helpful in the fact that it just compiles literally everything that NIST is doing on the CHIPS program into one location. So you don't have to go searching around through all these different articles, figuring out what the latest, greatest has come out on this program. So that's up and running. Highly recommend checking it out. They also released the results from a request for information that they put out actually before the bill even became law, because they knew it was going to, or most likely going to. So they were preparing ahead of time on how to set up the incentives program, as well as the institutes that they're planning on establishing through their R&D programs. We submitted comments to that RFI. I know many other people did as well. And the results that came out that they released, optics and photonics, is mentioned several times throughout the RFI, so much so that they have like a it's listed as a reference at the end of the document of all the mentions of photonics. So really good that it was a very heavily covered topic. Same is true for NIST released an outline of strategic opportunities for U.S. semiconductor manufacturing. Again, optics and photonics heavily mentioned throughout that report out of OSTP. Out of NIST. So it was a very good document to show that like clearly optics and photonics is a heavy role to play in implementing these programs. And then the administration also released their implementation strategy for the 50 billion Chips for America Fund. Definitely worth checking out if you haven't already, because it does give you an inkling of kind of criteria for they're going to be looking for when it comes to applications for proposed funding. So it gives you, I mean, it's big picture. You won't get the details until we see the actual request for proposals, but it does give you kind of big picture what they're going to be looking for. And then also NIST and Google announced the creation of a new supply of chips for researchers and tech startups they're working on as a joint project. So these are some of the more recent things that have happened. I have one last slide. And then the most recent thing, and actually it's current, is there's 2 Federal Register notices currently active and open for comment. One is seeking input on the design and implementation of the incentives program. And then the other one is requesting information on the Manufacturing USA Institutes to set up those institutes. So definitely take advantage of this opportunity to provide input to them on direction they should take the CHIPS program overall. The comment periods end on November 14th and November 28th respectively. So not a ton of time there. So if you have not taken a look yet, please take advantage of this opportunity. And that is my last slide. Walter? Oh, you're muted.
Thank you for that federal overview. I think this is a great time to pivot and start talking about sort of a local perspective. And Jennifer Fowler is within AEDC, but she is the director of the Arkansas NSF EPSCoR program. And I'm happy to have Jennifer present a local perspective today.
Thank you. Hello, everyone, and thank you all so much for joining. Again, I'd like to really say a special thank you to the members of our legislature that are here today and some of the other researchers and names that I recognize. I think it's going to be really important to have you guys in this conversation, especially moving forward. So just really quickly, a little bit about myself. I am located at the AEDC here at the Department of Commerce in Arkansas, and I manage the Arkansas National Science Foundation EPSCoR program. So I'm the principal investigator for the current EPSCoR Track 1 project, DART, which stands for Data Analytics That Are Robust and Trusted. Most of my experience has been with NSF, so things might be a little NSF focused in this the next few slides. And I did my undergraduate at Fayetteville, and I'm right now pursuing my PhD at A-State. Let me see if I can get it to work. Okay. There we go. Maybe. All right. So basically the points I want to get across today is that, you know, like we've talked about a little bit already, we have a very unique, some very unique advantages in the state of Arkansas that position us very nicely to take advantage of some of these opportunities that are coming. But it's not going to just happen. Like, we actually have to do things to make it happen and to receive the funds and to take advantage of these opportunities. And we really need to work together to do that. And it's going to take some interesting and new approaches and some new partnerships. It's not going to be easy, but if we do it right, we really could transform the state and our economy and put ourselves on the map as a leader in this space. So a little bit about EPSCoR, if you guys are not familiar with this, just because it's an acronym that we've been throwing around. I wanted to talk a little bit about why this is relevant to the conversation today. EPSCoR is a federal research program at multiple federal agencies, including NSF, NIH, NASA, and some others shown on the screen here. It's designed for states that are not receiving a lot of federal investments, and each agency has their own calculation of how they determine eligibility for EPSCoR. For NSF, right now the criteria is around 60 million a year. So if you're getting less than 60 million a year in NSF awards, you're eligible for NSF EPSCoR. So you can see on the map that that represents more than half of the country. Right now we have 25 states, and then Guam, Puerto Rico, and the US Virgin Islands are all eligible for EPSCoR. The reason EPSCoR was introduced in 1979 is still an issue today. So there are some conversations at the national level that it has not been as effective as we hoped. But there are some changes coming that will hopefully reinforce this strategy. But as you can see on this map, so this is a map of federal year or fiscal year 2020 federal R&D obligations by state. And it doesn't take very long to look at this image to realize that the federal R&D obligations are extremely concentrated in two states, California and Maryland. In fact, in fiscal year 20, California and Maryland received 26% of all federal R&D investments. And so EPSCoR has been a strategy that the federal government has been using to try to address the inequity in the distribution of investment in federal research funding. And so there's a lot more work to do. And EPSCoR has been named specifically in a lot of the communication related to the CHIPS Act. It is specifically addressed in the CHIPS Act and also in some of the other solicitations that we've seen coming out as an example of collaborative public-private partnerships and potential model for new programs coming forward. So the CHIPS Act provision for EPSCoR actually will provide significant increase in funding to EPSCoR states. In fiscal year 20, the National Science Foundation allocated around 2% of the $8.8 billion budget that year from the agency. So it was about $192 million specifically set aside for EPSCoR through NSF. EPSCoR states were able to compete for an additional $982 million that year. And so in FY20 combined, all 25 states plus the 3 other territories or whatever you want to call them that are eligible for EPSCoR only received 13% of the whole agency's budget. So 13% of $8.8 billion across all programs are going to more than half the country. So the CHIPS Act actually included a provision to increase the set aside of the NSF budget to 20% by the year 2030. So this is a huge increase in funding that's going to be coming down over the next few years in a kind of a structured fashion, a slight increase each year based on appropriation, of course. And basically, this is going to provide a huge flush of money that's not just for semiconductors or not just for the topics that we're talking about today, but for research funding in general for the state. So one thing I wanted to mention is that I've noticed in a lot of the conversations and some of the new programs that are coming out related to the TIP Directorate, which the other Jennifer was just describing a little bit, is that it seems like the government is approaching this kind of strategy of cooperative agreements more than standard grants, which has kind of been the historical investment strategy. So in a standard grant, the federal agency would issue you'd compete for the grant, they'd issue you an award, and then, you get the money, you do the work, and then maybe you submit a report at the end and say, hey, thanks for the money, we did what we said we were going to do or whatever. In a cooperative agreement, you only receive your award at small increments. So that could be on a 1-year increment or a 2-year increment. And you are evaluated a lot by lots of different people. It is very annoying, but usually productive. I spend a lot of my time doing a lot of my day is related to evaluation and reporting because EPSCoR is a cooperative agreement program. So we have an external project evaluator, external advisory boards, industry advisory boards. There's a state committee. You'll have special review panels every 1 or 2 years. And pending approval from all of those entities, the agency will release your next round of funding. And so with EPSCoR, that's 1 year at a time. And with the innovation engines, that is going to be 2 years at a time. And so they made it very clear in the webinars and FAQ sessions they had with the NSF regional innovation engines that they are expecting failure. They are going to evaluate those projects on a 2-year basis, and they are expecting some projects to fail that they will be able to then reinvest that money in a new project. So I thought that was really interesting. Just really quickly, I wanted to show you, we're still, while we have seen an increase in general in investments to the state of Arkansas, we're still not getting a whole lot. So this is all of the NSF awards to Arkansas from 1970 to 2020. So 1979 is when EPSCoR was implemented. And so you can see after EPSCoR became a thing, we started seeing an increase in funding. And this is all of the federal R&D obligations to our state from 1999 to 2019. This is data that I pulled from NCSES. And so again, we've had a spike there in 2016. I didn't look up to see specifically what award that was, but this is across all federal agencies. Slight increase over time, but still not a huge improvement. Why is this relevant to innovation and the semiconductor ecosystem? Well, these basic research and applied research funding projects from our federal agencies often or ideally will result in intellectual property. So this is just a quick chart I wanted to show you guys that shows the number of patents and number of startup companies that were affiliated from EPSCoR investments over the past NSF EPSCoR investments since 2010. So those 2 5-year projects, Asset 2 and CASE, had a significant number of patents and startup companies that spun out of those. And then we also had a few from the Plant Imaging Consortium. So this is really the whole point of what the Division of Science and Technology here at AEDC, how we function. We want to be funding research, really exciting research that's happening on the campuses through the EPSCoR projects, and then be able to funnel that into our knowledge-based economy, using the incentives and programs that we manage here at AEDC to support our entrepreneurs and help them commercialize that technology from lab to market. And you will probably recognize some of these names of our EPSCoR affiliated startup companies, most of which have been pretty successful, including one, Ozark Integrated Circuits. So Matt is our superstar example of an ideal kind of, I want to say an ideal pathway, but really he kind of blazed the trail for a lot of people that came after him, which I'm very appreciative of. But one thing that Ozark Integrated Circuits has been extremely clever at is figuring out how to piecemeal together the state and federal incentives to grow the semiconductor business that they're running here in the state of Arkansas, and then also hiring the students that are coming out of the University of Arkansas and our educational system and retaining that talent in the state. So they're really a rock star example of what an EPSCoR kind of startup or science-based startup could look like. So the other names on that list, like I said, y'all will probably recognize some of those. Some of them are older, some of them are newer, but we're very proud of all of them. And we hope to have a lot more coming down the road because we recently were able to announce that we have the most amount of national I-Corps teams participating in the NSF program of any EPSCoR state because of a new collaboration that we've had with the University of Arkansas. We've been able to significantly increase the number of researchers and graduate students and industry mentors that are participating in the NSF I-Corps program. And I'd be happy to talk more about that later if anybody has any questions. So the NSF piece is pretty relevant because they are going to be getting and administering a big chunk of the CHIPS money. So this is a quick chart from McKinsey that I found online that shows kind of how some of this money is going to be allocated. And that's why I wanted to place a little bit of an emphasis on the National Science Foundation specifically. A lot of the funding is going to be available through them. They have announced already a Dear Colleague letter for new tracks in some existing NSF programs for workforce. And so I've seen a lot of comments and questions about workforce development and education. This is kind of one of the first steps that NSF is going to be taking in that direction. So they actually have added some new tracks specifically for semiconductor manufacturing education in 2 existing programs, the ATE program and the STEM programs. The ATE has deadlines in October of next year, so that's plenty of time if anybody is interested in pursuing something like that. The STEM program, those deadlines are in February, so that's coming up pretty quickly, but there is a link there that you also will be receiving in the follow-up email for this event where you can get more information on these programs and how you could apply to take advantage of these workforce opportunities. But as the other Jennifer mentioned, most of these solicitations have not come out yet. So this money has not actually been appropriated. As a government employee, I can tell you we keep our eyes on the news related to potential shutdowns. And, unfortunately, until the budget is approved, the federal agencies will not be able to announce a lot of solicitations. But over the next 6 to 12 months, we will be expecting lots of solicitations to be coming out from all of the federal agencies that are participating and receiving funding through the CHIPS Act. This is just some recommended reading. I'm not going to talk too much about it because it's been mentioned before, but there is a strategy document that was published in early September that outlines some very, very detailed information, including what potential applicants can do to prepare themselves and get ready to take advantage of this funding. If you have not already read the National Science Board Vision 2030 report, I would highly encourage you to do so, because that is the governing body that really sets the pace and priorities for all federal research investment. So that is a really good place to learn where the federal government is, looking in terms of the topic areas, research areas, and, focus areas that they're going to be investing in over the next several years. And then, as mentioned earlier, there is an open request for information right now for the CHIPS implementation of the CHIPS incentives program. And the deadline for comments for that is November 14th. There are not a lot of comments right now, but there were over 200 that were published in their last request for information. And you'll receive that link in your email as well, but you can read through some of the comments from their earlier RFI that they published in January. I highly recommend, especially those of you in industry, to get in there and make your voice heard when you have opportunities like this. So I have a couple of slides here with some really interesting language that I found. So I'm kind of I have a procurement background, and one of my skills, or whatever, one of my areas of expertise is being able to sort through all of the bulky, cumbersome solicitation language that some of these agencies put out. I do offer this as a service to researchers in Arkansas. So if you ever find a solicitation and you're having a hard time figuring out exactly what the heck it says, feel free to shoot it to me via email and I'll be happy to parse through it for you. So this is some language that is in that strategy document that NIST published that I thought was particularly interesting and a little bit different than what we've seen from the federal agencies in the past, that I wanted to just note for you guys really quick. So one thing I thought was interesting is that they will be expecting, especially for the larger programs and the centers that the other Jennifer mentioned, they will be expecting you to have a significant cost share. And they want you to look at really creative ways to do that. So this is not your traditional just matching, grant type funding that they're looking for. They want proposals that are going to be leveraging private capital and coming up with creative financing structures. I thought it was interesting that they specifically stated to tap a variety of sources of capital at different places on the risk and reward spectrum. So they're really looking at comprehensive and creative approaches to how the states and regions that are asking for these investments are going to also make a priority to leverage all of our effort and all of our other investments in the state and, make this a key priority. They also encourage the state and local governments and agencies like AEDC to come up with new creative incentive packages. A big part of the CHIPS Act is set aside for tax credits and tax incentives. And they really want to see that the state is also interested in supporting this economy and ecosystem. And so they're going to want to see some new incentives and new programs in terms of state or local level support for the companies and research and workforce that are going to be supported under this effort. They do encourage, outreach and especially in rural areas and to marginalized communities. And I thought it was interesting that they specifically stated in there that they would encourage proposals with comprehensive workforce support like childcare, transportation, alternate language needs, internet, broadband internet. And they specifically mentioned, jobs that have good wages, benefits, and or are unionized. So there's some language in this report about the types of jobs that they expect that there will be a large demand for, and that includes things like welders and pipe fitters and stuff like that. It's not all just engineering PhDs that are going to be needed to pull this off. And so I just wanted to point that out again. I thought that was interesting that they specifically called this out. And then they did mention that they want to increase the participation in these marginalized communities, support minority-owned businesses and veteran-owned businesses, women-owned businesses, which is something else that we do here at AEDC, and try to spread some of these investments around in better geographic diversity than what's currently being done at the national level. So my final slide, what can we be doing right now? So we've talked a lot about the fact that these solicitations are not coming out, the money has not been appropriated. What can we do right now to get ourselves ready to take advantage of these opportunities? Number one, provide your comments to that open RFI right now. Read everything that is coming out on chips.gov. So go on chips.gov, sign up for newsletters, go to NIST, sign up for their newsletters, whatever agency is like your agency. So if you're a biomedical person, you're interested in this, all of these agencies that are getting involved, DOE, DOD, NSF, whichever one is your flavor, go on there and sign up for the newsletters so that you get the first notifications when these solicitations are published. And you'll also be informed whenever they're having webinars or office hours or chats with the program officers and all that kind of stuff. Get your DUNS in a row. If you do not have a DUNS number and a SAM number, you are not going to be able to receive any federal funding. So you need to get that stuff taken care of. There are some changes to the SAM.gov unique identifier stuff right now. So if you have received an award in the past, but it's been a long time, get all of that stuff resolved now. That can take a long time to do, especially over the holidays. And you want to make sure that when those solicitations come out, if it's a quick turnaround, you want to be able to apply and submit your proposals. And then my last point is that we need to continue these conversations and also grow these conversations. I think I'm really thankful for Walter and Power Technology for hosting this today and starting this, initial talk and discussion on these topics. I think it's very important. And like I said earlier, if we can really do this right and come up with some innovative and collaborative partnerships, that we can really, really transform our state and really leverage efforts like the innovation engines and like the CHIPS Act and all of the other new things that are coming down that are going to be available to us. So if we do it right, we can really do something awesome for our state. So thank you all, and I look forward to having further discussion for the remainder of this event.
Well, that's awesome. So appreciate everybody presenting today. So just to recap real quick before we get into questions and answers, we've learned what the Chip and Science Act is. We've learned about the federal funding that's available. We've learned a little bit about how federal funding works as it flows to Arkansas. And then we've heard about the semiconductor industry that's vibrant and active in our state. So want to transition to questions and answers real quick. And we've had a couple of questions and answers submitted from the chat room. So I want to start with one about workforce. Jamal asked, multiple panelists mentioned workforce development being a top priority. What are some steps, in your opinion, that either the federal or local government can take to support this effort? Well, that's a great question. I know some of the legislative members that are here are very keen on workforce, but I'll take a first stab at this, and then we'll open the floor up for other comments on this question. But specifically in the area of photonics, we do have some specialized training that already exists in the state of Arkansas. The Pulaski Technical College here in the central part of the state offers specialized photonics training that's based on a layer of electronics training that they offer. I know there's a optical side of that training, and so that is an opportunity for us as well. So Jamal, if we can open up the microphones for the audience, is there any other training that the workforce is available to workforce that anyone else knows about here in the state?
Walter, I'd just like to comment on LaCroix's experience. We're part of an optics manufacturers association, and the association has been developing a optics technician apprenticeship program. We are the first optics company in Arkansas to implement this nationally accredited optics technician apprentice program in the state of Arkansas, and actually in the United States. And so what we do is we partner with a community college up in New York State that is kind of located in a optical manufacturing hub. And so our apprentices take courses multiple times a week, and combine that with work experience. And the program, I believe, lasts about 2.5 years. But when they complete their program, they have they get a certificate. And so far, that program seems to be working pretty well for us.
That's great. That's great. And are those people from New York coming to Batesville to perform some of their apprenticeship?
So what we're doing is they're doing online remote learning on a day-to-day schedule. And then our apprentices go up there once or twice a year and spend about 10 days doing some lab specific work.
Awesome. Awesome. Well, that's great. Love to hear about those kind of training programs. So if anyone else knows of other training programs that might help the semiconductor industry, you may have to type it in the chat. I'm not sure that we have the ability to unmute all of the attendees' microphones, but if you have something to comment, you're welcome to put it in the chat.
I did just want to point out, I put a couple of links in the chat. I would be remiss if I did not mention the things happening, the opportunities and resources here in the Department of Commerce in Arkansas. So I know that the Office of Skills Development has received Department of Labor funding to provide grants and support for apprenticeship programs. And it's pretty flexible in terms of the topic. So I'd highly encourage people that are interested in taking advantage of that to contact the Office of Skills Development. Mark McManus, I believe, is the guy that you need to talk to, and I could probably facilitate that if needed. And then also here in AEDC, the Manufacturing Solutions Unit, they provide an array of services and advice, including training and other workforce development kind of support programs to manufacturers in Arkansas. So I did drop both of those links in chat. And I also put the link for the NSF announcement on the 2 new workforce training programs specifically related to semiconductors.
Awesome. Awesome. Okay, well, I see another topic in the chat room from Sam Birchfield. I'm not sure if I understand it fully, but Sam says, given the need to onshore semiconductor manufacturing, what other Arkansas companies currently supporting the panelist? So Sam, if you could help clarify that a little bit, or if anyone wants to take a stab at an answer, I'd be happy to hear another perspective on it. So briefly, based on what little I understand there, Sam, we have quite a number of companies involved in semiconductor manufacturing in the state. I've been able to assemble a pretty comprehensive list with the help of many people, including Rebecca at ASBDTC and Jennifer and some others. So we've compiled a pretty comprehensive list of companies and individuals. And so there's more people involved than we see here on the panel today. And we'd be happy to take another stab at an answer if Sam's able to clarify in the chat.
I'll put something towards Jennifer. ADT's done a wonderful job in the past of highlighting different industries in Arkansas. I wonder if this is something we could work on together to highlight with the CHIPS Act coming, to highlight the semiconductor industry in Arkansas.
Yeah, absolutely. I think that's a great idea.
So Sam added to his question in the chat, says, yes, Walter, talking about supply chain shortages, I was curious what everyone is doing to utilize vendors from North America. So Kirk, you want to take a stab at it? I mean, without revealing trade secrets.
Sure.
Is there any onshoring of supply chains that you've done over the last couple of years?
So traditionally our business has been manufacturing volume optics to support domestic supply chains for the medical industry and scientific industry. Typically, our biggest competitor have been Chinese manufacturers. And so over the years, we have seen that business get more and more competitive, and we've lost customers over the years to Chinese or Asian manufacturers. Over the last couple of years, we've seen some of that business start to come back. So we do see some companies, some OEM device manufacturers wanting to reshore or nearshore their manufacturing in order to secure that supply chain. What's really interesting for us is, and I speak for our whole industry, the optics manufacturing industry has never been busier, not only because of the high demand for semiconductors, but also just the role that optics play in these emerging technologies that are that move kind of our world forward, whether it's the Internet of Things or self-driving cars, you name it, optics plays a role in that technology. So we're seeing huge demand, but unfortunately, we have the same supply chain challenges as everybody else. So if we want to buy a new manufacturing machine right now, instead of an 8-week lead time, we're looking at 14 months. So it's really challenging to meet the demand with the challenges to our supply chain.
Yeah, I can answer for power technology. I mean, we've historically depended on a number of suppliers in Asia, Belarus, and Russia. And so those 3 geographic areas and the events relating around them have led to a constraint on our supply chain. And so we have adapted well by finding alternate vendors that aren't in those areas. And in some cases, we're simply having to redesign a product to use a more available component. And so the impact for us has been that it's increased our engineering hours and taken away from the ability to manufacture new products. And we spend all of our time, re-engineering legacy products because of supply chain issues. And so that's been the impact for us. Anyone else have a thought?
I'd like to, oh, go ahead.
I was gonna echo, we on that tail end, we've had that same issue of, so actually even some of our more mundane things we have to do, we end up having to spend time in re-engineering them because of availability of components. It's been, that was we always have had supply chain issues being in mil-aero. We almost exclusively have to use US supply chain, and it's an exception to the rule for a lot of our customers to not. But I will say for us, it's been really interesting. Even before the CHIPS Act, there's been a push from the military side to stand up things. So I think we need to thank some of those folks that got the ball rolling for what led to the CHIPS Act. It could start start screaming. As the last call I was on, they said it affects, it's always affected the F-35. Now it affects the F-150, and people care. So we found that the supply chain in the U.S. has always kind of, some of it's been there. It's just, has it been competitive, or has it been open? It's been captive. A lot of for example, a lot of the semiconductor that we would want to use, it was captive, and with encouragement has opened up. And so now 4 years ago, all my silicon carbide was processed overseas. Now it's all processed in the US. We have multiple commercial fabs. So, the industry sort of recognized that this is critical for a lot of different applications and gotten behind it. And so we have some momentum there. But the other part of it that we have had to do beyond the chips is we've honestly had to help stand up domestic suppliers for some of our components. So find companies that are merging and have a good idea and sort of guide them towards how they can get incentives through R&D and other programs to kind of finish the thought and become a US-based supplier for us. So it's we spend a lot of time working on supply chain and not product. But that's kind of been for us in the mil-aerospace been part of the job for a long time.
Okay, awesome. Jennifer O'Brien.
I was just going to highlight, I think I mentioned it in the criteria for the incentives, a requirement that companies do kind of justify their supply chain and prove that it is a secure supply chain. So if companies haven't, I'm sure it's something on people's minds already, whether their supply chains are secure, but of course, to receive those funds, you are going to have that information in order.
I just wanted to add that
All right, awesome.
to keep in mind, everyone, that we do have
Of course.
significant.
Connection.
Did my internet, I glitched up. Can you guys hear me?
Yes.
Okay. Yeah, this is the state internet, so here we are. I just wanted to remind everyone that we do have some outstanding talent at our higher education institutions in the state. So people like you, and as he mentioned, he's one of very many talented faculty at the University of Arkansas. That talent is not exclusive to the University of Arkansas. We have some really interesting capabilities, facilities, and talent at other campuses throughout the state. And so I really encourage manufacturers and businesses who are facing those supply chain issues to reach out to your local campuses to try to see if there's any way that you can take advantage of industry and academic relationships to try to address some of those needs.
Yes, absolutely. Well, our next question actually comes from the U of A. So David H. Would like to hear about the thoughts of industry members on how they see research and prototype facilities at the U of A supporting their technology advancements. And certainly, he says the university and the researchers play a major role in workforce development, but the U of A is also well poised to contribute to tech development through partnerships. And so, industry, what do you think about the research and development facilities and the prototyping of support at the U of A? Well, I, for one, very pleased with what I see at the U of A. I've recently been to the U of A looking at some of the intellectual property opportunities that are there. The one I was looking at wasn't quite mature enough for us to get involved with on that project, but we found another project where we may have some ability to collaborate. So, that would be just Power Technologies' perspective on what's happening with tech transfer at the U of A. All right.
Yeah, I'll just offer is that we, obviously we wouldn't be here if it hadn't been for the U of A. We have 20 employees, and I think at some point I counted up 38 degrees. So we've got what's between their ears. They learned a lot of them learned at the U of A and at other state institutions. So that the primary thing is that students get those experiences. That they learn skills that are relevant to the companies. That has to be absolutely first and foremost. As far as working more together, I think there's an opportunity. I think some of the things that they're formulating in how the CHIPS Act is going to roll out that Jennifer highlighted, I think the U of A should really get ahead of and think about how, a lot of times in growing their programs, they've been very outwardly focused towards what can we, pulling in the federal money and the strategies there. Now, if we look through some of these programs, how do we look Arkansas based and make sure that money then that investment does work well with the companies in Arkansas. And so I think the CHIPS Act is a great focus, since we obviously have existing semiconductor industry in Arkansas. We have semiconductor research, and getting some really meaningful panels and advisory groups together around the table. I think I think that's an opportunity for sure.
Yeah, awesome. I agree. So we have a couple more questions to get to, and if you have any questions that you want us to address, feel free to drop them in the chat. But the next question is, what can academia do better to put photonics in front of students who would otherwise study different engineering concentrations?
Well, I thought the first rule of photonics is don't stare at the laser. So I don't know if we're supposed to put them in front of them. Okay.
Very good point. We have a lot of pirates walking around here. You can,
Yeah.
no, I'm kidding. Never, never. I think that's a great question. You know, I think photonics and semiconductors have a little bit of a marketing problem. I think everybody thinks that the industries themselves are attractive, but you know, what I have found is getting into schools, you know, taking some lasers with me, taking some product with me has really been engaging to the students. You know, really encourage industry to actually get involved with academia. And, you know, when I was chairman of the Arkansas STEM Coalition here, the statewide nonprofit, you know, we saw constantly that academia and industry didn't speak the same language. But really, we have to make an effort on both sides to get into each other's facilities. You heard Jennifer Fowler perhaps mention Manufacturing Day as a really good way to open your doors and let students and academia come in. Unfortunately, that's only once a year. But, you know, as industry, we have to engage with our local schools, and not just the school down the street, but the school 10 miles away, 20 miles away. You know, think about the driving radius that your people come to work every day from. You know, I might need to go to Cabot. You know, I've had employees come from, you know, 30 and 40 minutes away. So I think that's one thing that industry can do is just get in the school, talk to the career class, pick up the phone and call the school, and they'll tell you how to get engaged.
Totally agree. And, you know, and I think there might even be some things for us to be thinking forward as what with funding. I said, I teach a robotics electronics group every week, and started 5 years ago. And I now have 2 employees that work full time for me that came out of that happened to be in a small rural community where I live. So yeah, you do have to look, you know, look, you don't have to look that far. In Arkansas, that's one you can live in you can work in the second largest city in the state, and 10 miles away you can be in the countryside. So our industry has that opportunity to have a really broad outreach because to groups that would need to be reached out to. It'd be a lot harder to do if you live in, you know, if you're in the middle of the Dallas Metroplex to reach out, right? So, but the other side of it is, you know, maybe where there's some concrete ways we can do this and make this happen is, you know, I have people here that actually, because a parent came to me, they started interning in high school. So, you know, before they even went to college, they got to see what we do and how we make things that steered their whole career. And in some cases, it led to them into working for us or working for other similar companies here in Arkansas. So, you know, if there's ways to create incentives for companies to, you know, because it takes time to do that and it takes money to do that, to get as you know, get high schoolers in, get college kids into our companies and see what we do. I think that's another great, you know, even some low-lying fruit there, because you know there's no substitute for doing it and getting excited about it.
Yeah, I agree. Anyone else?
I'll just add that, you know, this outreach is super important because the workforce development is, you know, it's really a pipeline, right? So we have a material science and engineering graduate program here at U of A that has a big emphasis on photonics and optoelectronics, but, you know, marketing was mentioned, right? We need to get people, you know, in high school or younger excited about this area so that by the time they are finished with their undergraduate work, they might be interested in a program like ours.
Absolutely. Absolutely. Well, our next question comes from Kim Tran. Has any mapping of the industry been done to see what gaps could be unique and competitively filled by Arkansas manufacturers? So that's a great question. Has anyone done any mapping of the industry, the semiconductor industry here?
I think that, this brings up to Matt's earlier point that this is one of our kind of industry sectors that AEDC, we have not fully explored. So I know that we do not right now have a map, but I would very much love to work with Walter with the information that you've been compiling, and Matt and everyone here and the AEDC marketing team to and manufacturing solutions as well, to try to put something like that together. I think that that will be a very productive next step in terms of preparation of what we can do to make sure that we're well poised to take advantage of these opportunities coming. And I think it would be very important to have that information. So I'm 100% on board to try to undergo something like that. I don't think that there has been a comprehensive effort in that space yet.
Yeah, I agree. And I certainly don't feel the list that I've created is comprehensive, but I'm certainly willing to have that conversation and come to AEDC in person, in real life. So great question.
That would be great.
Great question, Kim. We appreciate that. And if you have any other questions, drop them in the chat box.
Hey, Walter, I have a question for Jennifer.
Sure.
As with an election coming up, and the governor's office will change hands, what will that do to AEDC? Will there be significant changes, or will most people stay in place?
So I will preface my response by saying that this is unprecedented in the sense that we have not had a change in the governor position since the transformation stuff has all been complete. So, we right now, what we're expecting, what I expect, and this could be, let me take off my ADC hat and just, this is me as a person in a non-official capacity. I think we can expect all of the secretary positions to be replaced at some point. It may not happen immediately, but I do expect all of the secretary level positions for all of the new 18 cabinet agencies or whatever will be replaced. And then, in terms of, is that going to happen before or after session? Who knows? The thing that we really don't know exactly what is unclear at this point in time is how many levels of leadership might be transitioned. So previously we could expect the director and deputy director levels to all be replaced with the incoming, new leadership. But with the new structure, we don't really know. But I can say that we don't expect any impact on the actual programming and services that we offer. A lot of the stuff that we do and the services that I've discussed today are coming from federally supported initiatives and federal funding. And so that should not be impacted. The only things that might be, if under a new administration and potentially new representatives in our legislature, there could be changes to programs like the science and technology incentives, such as our TTAG programs, SBIR matching programs, the accelerator funding, the TDP program, the R&D tax credits. Recently, those were all shifted to being funded by general revenue, which was a change from previous years. And that has impacted our ability to support our partners that take advantage of those opportunities in the same way that we have previously. But those programs right now, everything looks like it's going to be okay. I don't think that we can expect many changes that will impact our customers, even though we probably will have a new, Secretary of Commerce and potentially a new director for the agency.
That's a good question. All right. So, I think we've got just one or two more questions here, but I want to just acknowledge, 95% of the participants that started the call today are still with us. So that tells me this topic is really interesting. So the next question is, outside of a capital investment, what are some things that would best help businesses expand their business or their industry? And the question was specifically targeted to Walter, Kirk, and Matt. but I guess everyone can answer. So besides a capital investment, what else could be done to help you expand your businesses?
Well, I think we hit on a really good one already, which is sort of advocacy and awareness of what we do, because to get the resources we need people that want to do the jobs. So they need to be aware of this kind of work. We need lawmakers to understand what we do and the impact we make so that incentives exist so that we can expand. And then, and obviously the reason we're all here and all engaged today is to talk about how we make Arkansas competitive as this funding comes out. So I'm having a hard time thinking past that one right now, because it's one that's a personal passion for me, for not just my business, but all science-based businesses in Arkansas. That we do some fabulous things in Arkansas, and it's most people just know about Walmart and chicken and trucking, and I always just said one of my favorite quotes is, most people don't know that in dollars our major exports aerospace, and we do make things in Arkansas, and I think the science and the electronics optics side of that is something that I need help with. I think we all want help with.
Yeah, I agree. From my perspective, looking for the opportunities to collaborate. Arkansas is a great small town. If you want to look at it that way, we've only got 2.5 to 3 million people. And it's very easy for us to know each other a lot better than it would be, say, in California. However, we're familiar with each other, but we sometimes lack the knowledge about how we could collaborate. And I think we heard from Jennifer Fowler that that's really what's going to be required if we're going to secure some of this funding for our state, is figuring out what we can collaborate on. I know in the EPSCoR program, Jennifer has, for at least 2 or 3 cycles, had to find this overarching theme, for her EPSCoR program. But I think we're going to need an overarching theme, perhaps, so we can build these, coalitions within our state. And it may not be every person under the same umbrella. It may be that, Power Technology does something with Ozark IC, and that's a little umbrella, and maybe Ozark IC does something with another technology company, and that's another umbrella. But looking for those opportunities to collaborate really seems to be one of the things that we could use outside of capital. And of course, with money, we can solve a lot of different problems, and we can put someone on that topic specifically. But collaboration is probably one of the things that I would point out. We need to figure out what topics are important.
That's a great thought, Walter, because I said the CHIPS Act is an opportunity for us to really connect our supply chain together. That's already here. So that's a great point. I totally agree.
Yeah, absolutely.
Walter, I love that you brought that up, because I think collaboration probably needs to be one of the key takeaways, I hope, for everyone. And I did put a link earlier in the chat. I listened to a podcast on NPR called Throughline. It's a very good podcast, in case you guys have not heard of it before. But they did an episode recently called Silicon Island, and it's all about the Taiwan Semiconductor Manufacturing Company. And it really walks through the entire history of one of the main guys that founded that, and what it took for Taiwan to pull that off. It was not, like I said earlier, it's not by inaction, it's not by magic, it is by long, dedicated, and strategic work and effort on the parts of many, many individuals, ranging from talented engineers and the local government and venture capitalists. It was a huge lift to get them to where they are now. And so, I'm not saying that we'll be able to compete with the TSMC, but if we want to really make an impact, if we want to enact these, the visions that we've been discussing today, it's gonna take a lot of work, and it's not gonna be overnight. So I would just encourage everyone to just be open to those conversations, and I would like to offer AEDC as a facilitator for any collaboration conversations that you guys might need to have.
That's awesome. Well, I only have one question, and we'll use this question to sort of finish up and round out our time together. Let's talk about next steps. What would the group like to see as next steps? Does this, make sense where we want to try to bring some of these funds to Arkansas? And those of you who aren't on the panel, you can certainly type your comments into the chat. But what would everyone like to see as a next step for this group?
Hey, Walter, a few years ago, you and I talked about the Arkansas Photonics Industry Alliance. And it was basically our two companies and maybe a couple others, but obviously it wasn't a huge player in the state at the time. Given what's happened recently, and just from the discussions on this webinar here, to be able to recreate this organization for all of us to keep this conversation going, staying in conversation, it could help promote collaboration, as you all pointed out, and also help keep us abreast of the changes in this very dynamic situation. This may be the time to revive our efforts for that.
Yeah, absolutely. So one of those outcomes, I think I heard you say, could be to strengthen the Arkansas Photonics Industry Alliance, but also potentially stand up another organization, another alliance specifically geared towards semiconductor.
Sure.
Okay, that's a great possible outcome. I like that. Other thoughts or suggestions?
I think we should, I think, some sort of group makes sense. I think we should also probably be watching and see what happens, or be looking at what's happening in other states and see if we can learn and see what they're doing. Because I do think this is, it's very important for to be organized. I know I have run into some other stakeholder groups forming of different, not different cross sections, like small businesses versus OEMs and others. And so it's a evolving landscape, because no one knows exactly how the funding is going to roll out. But I think that's another thing is we should watch what's going on and see if there's things we can learn. We want to be competitive.
Yeah, absolutely, absolutely. I think if a group's created, I think one of the initial hurdles would be the simple creation of a website. Some of us aren't technically expert at creating websites, but having an identity online is critical in today's world. So, maybe getting a little funding for that or some volunteer work might be a critical step. Any other thoughts on what our next steps could be? I think we've somewhat agreed to get together with Jennifer and discuss some of the topics over at AEDC. We've talked about maybe standing up a group that's semiconductor specific, and then happy to have any other suggestions.
Yeah, I'll just add that I'm sure that not just myself, but others at U of A would be interested in being involved in those discussions to learn, how can we organize what's going on here to better serve the needs of Arkansas industry.
Okay, awesome. Well, I want to stop today and thank everybody for their time and participation. We're reaching the time that I allocated, and so I want to respect your time. I know you're all busy professionals, and I want to end on time. So I did want to let everyone know that our recording will be available on YouTube. If you go to the Power Technology page, we'll post the video up there so you can have that video. Also, slides will be available in a PDF format, and I'm happy to email those out to everyone who participated. We're going to need a day or two to put those together, but we'll do that. And everyone that registered today will get a copy of the PDF slides. And then in the future, as other groups get together and meetings are called, we'll try to keep you informed of those as well. All right. I appreciate everybody's time, and thank you all to the host and the panelists and the speakers. We're very grateful for your time and effort. We know it was a little bit of a challenge, and we're very appreciative. So with that, thank you, everybody, and we'll see you next time.